So this is part one of a two-part series on how to decipher and read chemical formulas and elemental symbols. Elemental symbols and chemical formulas are the backbone of understanding what the materials are in chemistry. So instead of writing out everything longhand with words, we use chemical symbols to describe a material, a compound, or an element. And we're going to use today's lesson is going to get us started down that pathway, understanding what is a chemical symbol and how do I determine how many materials or atoms and the type are in a particular compound. Okay, the first thing we have to understand is what is a chemical symbol. And a chemical symbol is simply a one or two letter abbreviation that represents the element. Sometimes the chemical symbol matches the start of the name of an element, and other times it doesn't. For example, the letter C is the start for the word carbon. So C, for the chemical symbol of C, capital C, stands for the element of carbon. However, tungsten, which is a W, stands for wolfram, actually, and that's where it gets its original name. But tungsten itself, the chemical symbol for tungsten is a W. Now here's the next thing that's very critical. If an element's chemical symbol has only one letter in it, it is always capitalized. So again, for example, if we look at the elemental symbol for carbon, it's a capital C, right? If an element's chemical symbol has two letters, the first is always capitalized and the second is always lowercase. There's never a chemical symbol that has two uppercase letters or two lowercase letters. So it's always uppercase, lowercase. And that's going to be important when we go to determining what type of atoms are in a chemical formula. So for example, here, let's look at neon. Neon right here, there's a capital N and a lowercase e, and that represents the element neon, the chemical symbol for the element of neon. Chemical symbols are unique to each element. In other words, there's no chemical symbol that is the same for two different elements. And each of these chemical symbols can be found on the periodic table. And the periodic table is a useful tool to scientists for chemical compounds, atoms, elements, and things like that. So there's a quick tutorial on what is a chemical symbol. Okay, so here are the periodic table, and the periodic table has a list of all the elements known and their chemical symbols. So the periodic table has the chemical symbols for each element. And notice that some of the elements, boron, carbon, for example, fluorine, only have one letter for their chemical symbol, and that letter is always capitalized. Other examples of two-letter chemical symbols are chromium, cesium, sodium, and for example, xenon, right? And notice that those chemical symbols always have the first letter capitalized and the second letter is always lowercase. Now don't forget that just because the chemical symbol starts with a letter, for example here in silver starts with the letter A, doesn't necessarily that the name of the chemical itself starts with that same letter. Because silver starts with an S, but the chemical symbol starts with an A. Same thing with lead. Lead starts with an L, and the chemical symbol for lead starts with a P. Okay? And also, there are no chemical symbols that have more than two letters. So you can have one letter, but you can't have three letters. So it's either one letter, which is capitalized, or two letters, which is first letter capitalized, second letter not. Okay, so how do we understand what are the elements that make up a chemical compound? And here is the very simple rule. You're going to count the number of capital letters, because a capital letter is the start of a new element. Okay, so let's look at that from a pragmatic standpoint right here, and we're going to go and count some of these letters. So I'm going to go to my first compound, which is HCl, and I'm going to put an underline for my first capital letter, and that's the H. And then the second capital letter is the C. Now, the third letter here could be construed or could be thought of as a capital I, but I'm telling you it's a lowercase l. So that does not count as a capital letter, so we're going to make that a little blue for lowercase. The next compound we're going to look at is NABR. And again, we're just going to look at which of the elements are capitalized, which of the letters are capitalized. So here's one. The second letter is blue, is going to be blue because it's a lowercase. Then we're back to capital, and then we're back to lowercase. All right? So as we go through this, and we're just looking at the capital letters, K, O is capitalized, and H is capitalized. And the last one, water, the H is capitalized, and the O is capitalized. We don't worry about the 2 yet. So now when we go through these, and we now have to tell you what are the elements in it, we look up the chemical symbols that are associated with each capital letter. So for the first one, we have 2 elements total, and they are hydrogen and chlorine. Now, the next one is 2 elements also, and they are sodium, and that's the Na. So if you look up on your periodic table, sodium is Na, and then bromine, that's the Br. Potassium hydroxide actually has 3 because there are 3 capital letters. It has potassium, and that's K, oxygen, that's the O, and we already know that hydrogen, I'm just going to abbreviate it hydrogen, and that's the H. And the last one, water, again, we have 2. One is hydrogen, and that's the H again, and then the other was oxygen, and that's the O. So the rule of thumb is, for every capital letter, that's the start of a new element. If there's a lowercase letter following a capital letter, that goes with the letter that just before it. So again, if we were to circle these real quick, let's use green. So here's my first capital letter, and then this is my second combo. First capital letter combo, second, third, okay? So you can see how this works, right? So the capital letter is the start of the next or the new or a new element, right? Not the lowercase, the uppercase. Okay, so if you followed some of my videos, you know at some point I give you a time where you're going to have to practice it. So this is one of those times. So what you're going to do when I tell you in a second or two is going to tell me what are the different elements in each one of these compounds, right? Do not worry about the numbers here, the 2 and the 4. They're not part of this particular question. I just want to know what elements make up this particular compound, what elements make up this particular compound, etc., etc. Okay? So I need a name and the chemical symbol. Now remember, the chemical symbol, the start of every new element, is a capital letter. If there's a lowercase letter after a capital letter, that lowercase letter goes with the capital letter before it as part of the chemical symbol. Okay? So you need your periodic table to help you with this. So I want you to stop the video in a second, work the problem, and then come back and restart to get the answers. So stop the video now. Okay, so here are the answers. And now let's look at why I got the answers that I did. So if you got potassium and chlorine for the first one, you did great. Sodium, oxygen, and hydrogen for the second one, great. Aluminum, phosphorus, and oxygen. All right, and then the last one is just bromine, right? I told you to don't worry about the numbers. The numbers have nothing to do with the element names and type, right? So how do we get potassium and chlorine? Remember, I told you to underline all the lowercase and uppercase letters. So if we just go by and put uppercase, 2 letters, 3 letters, 1, 2, 3. Remember, this right here is a lowercase l. All right, and then the last one is BR, and that's the only one. So here we have 2, 3, 3, 2, 1. And then you just have to look up each one. So remember, real quick here, the K by itself, the Cl goes together. The Na goes together, the O goes by itself, the H, etc., etc. Right? The Br by itself, the Al by itself, and then the P and the O go by itself. So if you got this, you did really well for the first shot, and now we're going to expand on this a little bit. So what happens when you see a chemical formula that has a number in it? Like this 2, or this 2, or this 3 and 2. What do these numbers mean in the chemical formula? What do they symbolize or signify? The numbers are called subscripts. And in a chemical formula, the subscript indicates how many of something there are. So a subscript tells you how many of the atoms or ions precede it. Subscripts only refer to the atom or ion immediately before it and not anymore. There is no subscript of a 1, and all subscripts are positive values. So what does this 2 mean right here? When you say subscript, it says here, tells you how many atoms or ions preceding it. Let's go back to math. And in math, let's say I had X, and I wanted to have 2 of them. How do you represent 2 X's? Well, you could say X plus X, right? The other way to write it is to say 2X. And if I wanted 3 X's, I could put it this way, or I could write 3X. The number here tells me how many of these X's I have. Now, we can't put a number in front here like that to indicate how many BRs, because that means something else to a chemist, and we'll get to that when we get to balancing equations. So chemists had to invent another way to signify that there are 2 bromine atoms in this particular compound, and the way they do it is with subscripts. All right, so let's quickly look at what these mean in real life. All right. So the 2 here means that there are 2 of these BRs. So let's kind of do it this way. This 2 indicates there are 2 of those things. This 2 indicates there are 2 of those things. Notice that there's nothing written here. That means it's 1. If there's no number written, it means it's 1, and it's implied it's 1. For example, you don't write ever when they say, well, you know, do you ever write 1x? It's very uncommon, right? Right? You just write x, right? So if you don't write the number 1, then it's implied. So there's implied that there's 1 oxygen, or otherwise we wouldn't list it, okay? So once we see this, now we know that this 3 corresponds to this thing. Remember, this thing is Ca, and this 2 corresponds to this N. The 2 does not correspond to this and this. It's just the thing that precedes it. So there's where it precedes. It stops right here. Okay? So that's pretty much the nutshell of how this works, right? The number defines the thing right in front of it. How many of those things? So if it's Br, it's 2 Brs. If it's H2, it's 2 H's. If it's Ca3, it's 3 Ca atoms. And that's it. It's nothing more complicated than that. It's a means of telling you how many of that particular thing, atom or ion, is in that compound. Okay, so let's see if you can put it together now. What I want you to do now is I want you to write the name of each element and how many of them are in each particular compound. So what you're going to do is you're going to look at this particular compound right here, K2O, and you're going to tell me what are the elements in there using your periodic table, and then how many of each element there are. So if you think that there are 3 potassiums, then you're going to tell me there are 3, right? So go through each one of these, tell me what are the elements, and tell me how many of each element you have. Right, so when you're ready to start, stop the video and do the problem, then restart the video. So stop the video now. Okay, so here are the answers. So you should have gotten 2 atoms of potassium, the K, and that's right here. The 2 tells me there's 2 Ks, and there's only 1 oxygen, so there's the 1 oxygen. In the next one, you should have figured out that Na is 1 chemical symbol, S is another chemical symbol, and O is another chemical symbol. And we have 2 of these and 4 of these, but only 1 S, 1 sulfur. Again, chemical symbol, the 3 goes with that. Right? And that's pretty much it. So this is end of part 1. So now, at the end of part 1, you should be able to tell me what the elements are in a chemical compound, and using the subscripts, tell me how many of each of those elements are in that particular compound.